From ground level in a bustling city, a journey across a continent feels immense. But as we pull away from the streets and break through the atmosphere, that familiar sense of distance is forced to change. The moon is 384,000 kilometers away. To cover that gap in a car driving at a constant 100 kilometers per hour, you would have to stay behind the wheel for over 160 days. From this distance, our home is a fragile sphere of blues and greens, cradled in a black void. It is the first hint of how isolated our existence truly is. Expanding to the sun, the numbers escape our daily intuition. Light makes this journey in 8 minutes and 20 seconds. If you attempted the same trip in a commercial jet, you would be in the air for 19 years. Within our own solar system, human-scale measurements of time and speed have already become ineffective. We are essentially trapped by the sheer scale of the space between worlds. Even our closest neighbors present a moving target. Because of orbital dynamics, the distance to Mars can stretch from 54 million kilometers to over 400 million. At its furthest, that same commercial jet would take 50 years to reach the red planet. At the edge of the solar neighborhood sits Neptune. It is 4.5 billion kilometers away, a distance so vast that sunlight itself must race through the vacuum for over 4 hours just to reach the ice giant. To bridge these gaps, we rely on machines like Voyager 1. Launched in 1977, it has traveled for over 4 decades to become the farthest human-made object in history, covering more than 22 billion kilometers. In 1990, at the suggestion of astronomer Carl Sagan, Voyager turned its camera back toward home for one final photograph before its mission shifted to the interstellar deep. From 6 billion kilometers away, the resulting image showed Earth as a tiny, faint dot. At this distance, our entire world and every story ever told are reduced to a single, easily missed pixel in the immense universe. Beyond the planets lies the Oort cloud and the heliopause. This is the boundary where the sun's solar wind is finally stopped by the interstellar medium, marking the end of our star's physical reach. The nearest star system, Alpha Centauri, is 41 trillion kilometers away. Because units like the kilometer are too small to be practical here, astronomers use the light year. Alpha Centauri is 4.4 light years from Earth. Current technology cannot bridge this gap in a human lifetime. Even traveling at 17 kilometers per second, the Voyager spacecraft would take over 70,000 years to reach this neighboring system. Zooming out further reveals the Milky Way, a spiral galaxy 100,000 light-years in diameter, home to hundreds of billions of stars and their own planetary systems. Within this structure exists the human radio bubble. It represents the farthest reach of our radio and television broadcasts, extending only 100 light-years from Earth. For the vast majority of our galaxy, humanity does not exist. Our signals haven't reached them yet, leaving our entire recorded history as a whisper that has yet to travel past our immediate porch. We are part of the Local Group, a cluster of more than 50 galaxies, including our neighbor, Andromeda. These galactic islands are separated by a silent, intergalactic expanse, millions of light-years wide. The Local Group is a small component of the Virgo supercluster. This structure is 110 million light-years in diameter and contains thousands of galaxies from at least 100 different groups. Beyond this lies the Laniakea supercluster. Spanning over 500 million light-years, this immense heaven contains the mass of 100 million billion suns. Laniakea is a gravitational web where galaxy clusters are pulled toward a central point known as the Great Attractor. This mysterious region exerts a massive pull on everything within the supercluster. In this context, our entire galaxy is a single speck flowing through a titanic structure, part of a cosmic web far larger than we can easily comprehend. Our exploration eventually hits a physical limit, the observable universe, a sphere 93 billion light-years in diameter. The universe is 13.8 billion years old, yet we can see objects 46 billion light-years away in every direction. This discrepancy means that light travel alone cannot explain the size of what we see. The answer is cosmic expansion. Space itself is stretching, increasing the distance between stationary bodies on the spacetime grid. At the furthest reaches, this expansion outpaces the speed of light. Light from these distant regions can never cross the growing gap. Consequently, entire galaxies are constantly crossing this horizon and disappearing from our view forever. They are receding into a depth we can never revisit. This creates a permanent barrier. The true size of the entire universe remains out of our reach, potentially extending into an infinite expanse that we will never witness. We are left with the realization that the observable universe is likely just a tiny fragment of the whole. We occupy a small speck in an ever-expanding sea, surrounded by wonders that are retreating endlessly into the dark.